Kia ora Year 12 and 11. This video is going to go through factorising like the examples in Theta 1501. So it starts off really easy and gets a little bit trickier by the end as usual. So the idea of factorising is that we go from having a sum of two terms like this to a product of two terms. That's really useful for us when we come to solve equations, and we'll get to that pretty soon. What we need to do is be quite systematic in how we approach them. First thing we're going to do is look at the coefficients, the numbers. Okay, so we look for the highest common factor of 4 and 12, and that's 4. So we're going to have 4 times something. Next we look at the letters, and I usually go alphabetically. The first variable here is x. So I've got an x in here, but I've got no x's over here. So x is not a common factor. Now I look at the y's. I've got y here but no y here. Y is not a common factor. So my common factor here is 4. So then we're going to have 4 times what to get me back to 4x? 4 times x. Plus 4 times what will get me 12y. It'll be 3y. So that's that one factorised. Notice that now I've got 4 times this thing here. Okay, so I've turned it into a product. In the next one, looking at the coefficients first, I can see that I've got a highest common factor of 3. So it'll be 3 times. Now let's look at the x's. I've got x squared here, x here, but I've got no x here. So there's no x common factor in this one. Again, it's just going to be the number. It'll be 3 times x squared plus 2x, because the 2 3's will give me 6, plus 3. So that's that one done. Okay, a couple more on the next slide. Okay, so these two examples are a little bit of a step up. Here we've got 3 variables in this first one. We've got d, e and f. So factorising, first checking the d terms. I've got d here, and d squared here. I'm looking here for the highest power of d that I've got, and it's just d to the power of 1, so just plain old d. Now I turn to the e terms. I've got e here, use a different colour, e here, e squared here, and e cubed here. So my highest common factor is just e. And now I look at the f terms. I've got f squared, f cubed, and just f. So my highest common factor is the lowest power, it's f. Right, now we go back to each term and see what we've got to times through. Well, I've got d, e, f. So I've got the d, the e, and I've got f, but I need f squared. So it's going to be times f. Minus. I've got the d. I need to have another e being multiplied in because I've got e squared. And I need to have f squared because that will get me my f cubed. Lastly, I'm going to have plus d e squared, and my f is all done. Okay, so that's that one fully factorised. Number 4, I've got a coefficient here of 24 and one of 40. I need to find the highest common factor of those two numbers. This is where students often start to trip up a bit. It's okay to use 2 steps if you can't immediately see that 8 is the highest common factor there, but better if you can get there in one hit. Next, okay, now we're going to look at the A's and the B's. Highest common factor is an A. So I've got A here, A squared here. And I've got a B squared here, but I've got no B thing down here. So here we've got 8 times what gives me 24? 3. And I need the B squared. Plus 8 times what will give me 45A. Right, on the next slide we get to a slightly trickier pattern that you might not have seen in year 10 or 11. Okay, so this immediately looks worse, but it really is the same idea. I've got 2 things added together. I've got 3 times x plus 1 and 6 times x plus 1 squared. So we approach it in the same way. We look for the highest common factor in the numbers, and that's going to be 3. And then we say, well, we've got this factor here of x plus 1, and here we've got a factor of x plus 1 squared. So I've got a common factor in there of x plus 1. So let's put that down there. Now, what do I have to do? What do I have to multiply by to get all of that 3x plus 1? Well, it's just 1. Plus 2 3's are 6, 2 times x plus 1 here, right? And that's because I've got an x plus 1 here And now I've got an x plus 1 here. And that's what I need because I've got x plus 1 squared. So we'll pop in our last bracket. I'm not finished yet, I have to clean up that third term. So we've got 3 times x plus 1 times 1 plus 2x plus 2. So collecting up like terms in there, I get 3x plus 1 times 3 plus 2x. When you're working through the exercise in theta, you'll find that towards the second half of 1501, there are lots of great examples like this. They're good for your brain. And the next one is similar. Looking here, I've got x plus 3 squared, and I've got a common factor here of x plus 3. So this one will be common factor of x plus 3 there, and it'll be x plus 3 here. Actually, I don't need to put that bracket in, just there, minus 2 times x plus 1. Cleaning that up, we get x plus 3 times x plus 3 minus 2x minus 2, which is going to just squeeze on this slide. I'm trying to keep it all lined up nicely, but it's getting a bit tricky. So there's x plus 3 times negative x plus 1. Right, so that's okay, but we would usually write that as x plus 3 times 1 minus x. Ask me about that in class if you need to. On the next slide, I've put some for you to try, and then I'll go through those. Right, so just 3 for you to practice. Pause the video and do these in your book, please, and just put a wee heading video for 1501 examples. So pause it and then restart when you've had a go at all 3 of them. Okay, answering them in blue. The first one has got a highest common factor in there of 12. So it's going to be 12 times 4x minus 5y. The next one has got a highest common factor in the coefficients of 7, and then we've got a, b. So then it's times 2a minus 5b. The last one has no common factor in the coefficients, but it has an x plus 1 common factor. So it's going to be x plus 1 times 4 plus 7 times x plus 1. So that's x plus 1. Now expanding this out, I'm going to get 4 plus 7x plus 7. So my final answer will be x plus 1 times 7x plus 11. Thanks for watching. That's all for now. Make sure you've done exercise 1501 in theta for lots more practice.